Hello friends, I welcome you in lecture number 40 on logic. In this lecture also we will discuss one more problem on rules of inference for propositional logic. Now we are familiar with different rules of inference and we have seen some problems that how we can check the validity of argument using rules of inference in previous lectures. In this lecture also we are going to discuss this one more example on determining the validity of argument. Here we are given one argument and we have to show that this argument is valid. So first we read what is this argument about. If there was a ball game, then traveling was difficult. If they arrived on time, then traveling was not difficult. They arrived on time, therefore there was no ball game. Show that these statements constitute a valid argument. In this argument, we can see that this last part is our conclusion and all these are premises. So as usual, first we have to translate this argument into symbolic form, and for that we have to first decide the statement notations. Here first statement is if there was a ball game. So we denote small p. Suppose small p denotes that there was a ball game. We denote this proposition by small p. There was a ball game. And then traveling was difficult. So let Q denote this statement that traveling was difficult. After that, here they have written that if they arrived on time, then traveling was not difficult. So we can consider small r for this statement that they arrived on time, and therefore there was no ball game, that is negation of p. Traveling was not difficult, that is negation of q. So we will require these three variables p, q and r for writing this argument into symbolic form. Now we can write down our argument in symbolic form. Therefore we have to write systematically symbolic form of given argument is, first statement is if there was a ball game, that we have denoted by p, then traveling was difficult. Traveling was difficult is denoted by small q. So this statement if there was a ball game then traveling was difficult can be denoted by p implies q. This is our first premise. Then if they arrived on time then traveling was not difficult. They arrived on time is denoted by r. So here if they arrived on time then traveling was not difficult. Traveling was difficult is denoted by q. Therefore negation q denotes the statement that traveling was not difficult. After that they have written that they arrived on time, that is denoted by small r, and all these three are premises, and conclusion is therefore there was no ball game, that is negation of p. So we write this here, p implies q, that is first premise, r implies negation q, second premise, r, and conclusion is therefore negation p. And we have to check the validity of this argument. We know two methods for determining the validity of argument. One method is use of truth table. Another method is using rules of inference for propositional logic. So we are going to use rules of inferences for propositional logic, and using them we will be able to get this conclusion after some finite number of steps. So as we have discussed in earlier lecture also, that here we will write down statements. We will write our proof as a 2-column proof. In this column I am writing statement, and here I will write down the reason corresponding to that statement. We start with first premise. We will use all these 3 premises and we will try to conclude that negation of P is the last statement. So first statement or first premise is P implies Q. So here we first write P implies Q, and what is the reason? Reason is that we are using premise. After that we write down second premise, that is R implies Q. It is R implies negation Q. So here also we write that we are using premise. Then we are taking contrapositive of second step or premise 2. R implies negation Q has contrapositive negation of negation Q, which is Q implies negation R. So what we have applied here, we are writing contrapositive of second statement or of second step. If you recall, if we have P implies Q, then contrapositive of P implies Q is negation Q implies negation P. Here we have R implies negation Q, so here we will have negation of negation Q implies negation of R. Now if you observe step number 1 and 3, then here you can see, here I have P implies Q and here I have Q implies negation R. So I can apply hypothetical syllogism on 1 and 3. So first I am writing the rule of inference which I am going to apply. Hypothetical syllogism on statement 1 and 3. So using hypothetical syllogism on 1 and 3, what I will obtain? I will obtain that P implies negation R, P implies Q and Q implies negation R. That will give me P implies negation R using hypothetical syllogism. Now what we can do is, here we want to conclude with negation P. Our conclusion is negation P and we don't have negation P anywhere. So in the next step we can take contrapositive of statement 4. So reason is contrapositive of statement 4, and contrapositive of P implies negation R is negation of negation R, that is R implies negation of P. So now I obtain R implies negation P, and I have not used this premise, so now I am using this premise. So here I will write small r, that is our premise, and I require my conclusion as negation P. So if you observe now step number 5 and 6, then here we can apply modus ponens rule of inference. So if I apply modus ponens on 5 and 6, we recall what is modus ponens. It says that whenever we have P implies Q, that is conditional statement, and here we have hypothesis of conditional statement, then here we will write conclusion. So if you compare these two with this argument form, then it is similar to this one. Here hypothesis is small r and conclusion is negation P. So using modus ponens we will obtain negation P here. So we can say that therefore given argument is valid. Given argument is valid. So in this way you can prove that given argument is valid using different rules of inferences. Now it is not necessary that you should start with first premise. You can use another premise also. You can start with another premise and you can obtain the conclusion by applying appropriate rules of inferences. Suppose instead of going in this way, I am going in another way. I will start with another premise. So that is also valid. It is not strictly required that you use this same sequence of statements to obtain this conclusion. If you wish, you can use your own sequence also. All you have to take care is that you are applying appropriate rules of inferences and you are able to conclude, or you are able to get your conclusion. So I am writing another way of obtaining this negation P. So here I write statement and reason. Here I started with first premise, that is P implies Q. Now I am starting with second premise, that is R implies negation Q. So let me write here. First step is R implies negation Q. What is this? This is premise. Then I am using third premise, that is small r. So let me write small r here. This is also premise. Now I can apply modus ponens rule of inference, known as modus ponens on statement 1 and 2. And we know that modus ponens says that if we have conditional statement and hypothesis of that conditional statement, then we obtain this conclusion of conditional statement. Or we know that now P implies Q and P, therefore conclusion Q. So if you compare with this, you can see instead of P I have R here, and instead of Q I have negation Q, therefore I have written negation Q here. Now I will use this first premise, that is P implies Q. So let me write here P implies Q, and that is nothing but premise. Here I have negation Q and I require my conclusion as negation P, and here I have P here. So I can take contrapositive of statement 4. Let me write first here contrapositive of statement 4. We know that contrapositive of P implies Q is negation Q implies negation P. So now you can see we require negation P as our conclusion. So you can concentrate on statement 3 and 5 and you can apply modus ponens here. If you compare this with this modus ponens rule of inference, then you can see our conditional statement here is negation Q implies negation P, and here we have negation Q, negation Q. Therefore using modus ponens, what we will obtain? Negation P. And I have to mention here that what I have applied, modus ponens on statement 3 and statement 5. So this is another way of proving that given argument is valid. Here I started with first premise, here I started with second and third premise, and in both the cases I am able to show that given argument is valid. So it is not necessary that you strictly follow this sequence. You can use another sequence also. All you have to take care is that there is no error or mistakes in applying rules of inferences. So here we have discussed that how we can check the validity of argument using different rules of inferences for propositional logic, and we have taken this problem. So we will continue with these rules of inference for propositional logic in upcoming lectures. Thanks for watching.